Hello, my name's Richard Brown and I'm Amenity Director here at Germinal. I'm going to talk to you today about what we've like to call climate smart landscaping, and essentially that involves looking at how we can reduce the amount of granular fertiliser we're using on landscape schemes, and also negate the effects of the fertiliser we have to use, because there are better types of granular fertiliser to use than some others. So essentially, Germinal, we're breeders, producers, and sellers of grass seed and clover products. Now, the important part there is the breeding part. We've been in existence since 1825, and we believe wholeheartedly that the breeding we do is integral to that longevity, but more so to our current relevance today and in the future. Now, up until 30, 40 years ago, we were essentially breeding for performance traits in grass seed and clovers. So, extra yield if you were grazing, or hard wearing varieties if you were talking about amenity types, those kind of traits. But of course, in the more recent past, we've been turning our attentions to the problem of the world in general, which is how to mitigate environmental change and be more sustainable in our approach, both agriculturally and on the amenity side. Most recent successes there have been on the amenity side. We've bred grasses specifically for Gulf greens use, so bent grasses that require far less fungicides than former varieties, so therefore are far more sustainable in that way. You're not applying those products to those surfaces so often. And on the agricultural side, we've had success with high sugar grasses, which are grasses which are far more digestible. So when the cows or the sheep eat those grasses, they have to work less hard to digest them, and they produce less methane as a result. So it makes the national herd far less polluting than it would otherwise be. And those grasses have won several awards, including the Times Innovation Award and the Queen's Award. So these are ways that we've already moved to mitigating our impact on the environment. So before we begin, I think the first thing we need to do is look at what the issue is with granular fertiliser. So what's the problem with granular fertiliser? Well, all granular fertilisers release nitrous oxide, and that's a fact. Some less than others, and that's what we're going to explore during this first part of this talk. But nitrous oxide is a greenhouse gas. It's 300 times as potent as carbon dioxide, and it's just as long-lived. So that's a problem if there's lots of that in the atmosphere, and we should do all we can as an industry to reduce that. So questions we're going to answer today, hopefully, is how we can negate the impact of fertiliser use, so how we can use fertiliser more cleverly, and which types of fertiliser we might want to choose over others. And we're going to consider, can we eliminate the use of fertiliser altogether? And I think the background to this slide gives you a suggestion that here at Germinal we think we can, but we'll talk about that as part of the presentation. So reducing fertiliser use. There are three ways to do this, as I see it, and we're going to talk about all of these. We can use slow release fertilisers, and I'll talk about those in a moment. We can use organic fertilisers, and we can create clean, free nitrogen by utilising clover. And we're going to take each one of those points in order. So firstly, granular fertilisers. Not all granular fertilisers are the same. The villain of the piece, if we want to call it that, we would say, is standard compound granular fertilisers. So quick release fertilisers, as they're largely known. And it's an amazement to me that over the last 10, 15, 20 years, we'll get landscape specifications through, and there is great efforts in that landscape specification to increase the biodiversity and environmentally sustainability of those products, of those landscapes you're creating. So by increasing the amount of species used, etc., putting a wildflower meadow in. But at the same time, in that same specification, there'll be that large urban amenity space, and there's a 696 compound granular fertiliser specified as part of that. And there's a real paradox there where using a different type of fertiliser would be a very easy environmental win. So compound fertilisers, quick release fertilisers, The problem with them is they're 100% cold water soluble. So what that basically means is they get wet and they release their nitrogen. So if you apply them on a cold day in November when the grass isn't growing, all of the nitrogen in that product will be released and not taken up by the grass, or very minimal amounts taken up by the grass, and volatilized into the atmosphere or leached potentially into watercourses. Now, of course, if you apply them at the right time of year, so when the grass is actively growing, an amount of that nitrogen will be taken up. But the fact is that even when the grass is actively growing, still about 60% of the nitrogen in quick release products is either volatilized into the atmosphere or leached into watercourses. They're an inefficient way to apply fertilizers. At the same time, I've put 4 to 6 weeks there, but it's really only about 2 to 4 weeks. They only really last for a short period of time. So if you're using them consistently to, say, maintain a sort of a parkland sports pitch area, then you're going to be doing more than one application over the course of a growing season. So let's look at what you could use instead of a standard compound granular fertiliser on a general landscape scheme. Slow release fertilisers. You could use a slow release fertiliser, and all slow release fertilisers, whatever their mode of action, will trickle nitrogen onto the surface in a far more steady and sustainable way. So you won't be getting that glut of release that the grass just has to catch, which is agronomically better for the grass sward as the first point, but also, of course, far more sustainable with regards to the amount of nitrogen you're applying over a period of time. Now, the first type of slow release fertilizer you'll hear about controlled release fertilizers. Now, the way controlled release fertilizers work are essentially they are that NP and K, that nitrogen, phosphorus, potassium prill, that compound granular we just spoke about, but coated with a plastic or, of course, more recently, a biodegradable coating. And all that does is that physical barrier has to be broken down in the soil, and as it's broken down, nitrogen is slowly released. The fertilizer prill is slowly released to the sward, so you're steadily over a 12 to 20 week period. So you've got that far more uniform, steady release of nitrogen, which is far more agronomically sound and far more environmentally safe. The other big advantage, of course, is because you are releasing nitrogen more steadily, you can apply more nitrogen in one go, because you know that you're not going to be losing a great chunk of that nitrogen into the atmosphere. So you can apply more nitrogen, and if you can apply more nitrogen and it's lasting 12 to 20 weeks, you don't have to apply it so often. So all that associated manpower cost and CO2, which is associated with spreading 2 or 3 lots of fertilizer, you can reduce by just applying the one once at the beginning of the growing season. I would caution, of course, if you're specifying controlled release fertilizer, you might want to ensure that that's definitely not got a plastic coating. Most don't now, but some still do. But of course, you don't want to be putting sort of microplastics into the soil potentially, and it can also damage mowing equipment. The old plastic shells sort of flick up and damage the blades on mowing equipment. The second form of slow release fertilizer, and there's more than 3, but these are the three main ones, is what's called ammonium stabilized fertilizer. So if you're specifying slow release fertilizers, you might come across an ammonium stabilized fertilizer. What does that mean? Well, essentially, again, imagine that compound granular prill, but just coated with what's called an ammonium stabilizer. Now, in order for grass to take up nitrogen, it has to be in the nitrate form, so NO3, which is negatively charged, as are soil particles. So that makes nitrate movable in the soil water, which it needs to be in order for grass plants or any other plants to take it up. But that's where it's at risk of leaching or volatilizing. Now, when in the ammonium form, NH4, it sticks to soil particles and remains in the soil. So it's not going anywhere. It's not causing any harm. Now, by applying an ammonium stabilizer to a standard prill, you can apply that fertilizer, and it has to be worked upon by the nitrobacter in the soil to break it down from the ammonium form into nitrate form. So as with the physical barrier, that takes a period of time. So the nitrogen is released more slowly over a period of time than it would be if it was just normal cold water soluble fertilizers. That's how an ammonium stabilizer works. Now, with these types of fertilizer, it's worth knowing that their release period will be quicker when the soil is warmer and there's moisture about. So when the nitrobacter are more active, so during the summer, then the breakdown will be quicker. but in actual fact, the grass will be growing more then. So, you know, it's working in symbiosis with the grass, and you're applying fertiliser when the grass requires it. So ammonium stabilised fertiliser, that's how it works. But the same principle, a slow, steady release of fertiliser over a period of time. And the third form of slow release fertiliser you'll hear of, they're generally just referred to as slow release fertilisers. But if you explore that, you'll find out they are methylene urea or urea form fertilisers. And generally all that means is that the slow release element of nitrogen is inbuilt at the processing stage. So there's a chemical process which essentially puts nitrogen into that prill in 3 fractions. A small part of the nitrogen, so say you've got 12% nitrogen in the bag, a small part will still be quick release, so will still be a cold water soluble element, and that will give you a quick green up, but it won't be the full 12%. Generally, about 65 to 70% of that nitrogen will be in what's called the second fraction, and that requires water and heat to break it down. So again, if you apply it ahead of the season when it's cold, it's going to sit there and not release its nitrogen because it's not warm enough for it to do that. It needs it warm and the moisture in order to break down, which of course is exactly what plants need to grow. So it's working again in collaboration with the plants that you're trying to fertilize. So it's far more agronomically safe and it stays in the soil. There is a third fraction in the chain, and that's basically that needs a nitrobacter to work on it as well. So there's a sort of third chain that needs breaking down. But essentially, you're looking at sort of 70–75% of that product, that nitrogen in that product, that's going to sit there and be released steadily and uniformly, and be less of a risk to the environment when you apply that product. So that's the forms of slow release nitrogen. The other, arguably a form of slow release nitrogen, is organic fertilizers. So organic fertilizers have a use in the landscape. Organic fertilizers are generally derived from plant or animal origin, and they're then pelleted into a form that is easier to apply onto landscaped areas. Now, those pellets need to be broken down by soil microbes, so the release period can be slower than that of a standard slow release fertilizer, because you haven't got that sort of inbuilt process. Depends how quickly and how healthy the soil is already as to how quickly that's going to get broken down. But they release nitrogen and they feed the plants around them. They also have the added benefit is in that you are applying an organic matter essentially to that soil. So they improve soil structure, and purely by improving soil structure, you're improving plant health. And because if you've got a soil with a good structure, where you've got good gas exchange, etc., then you're providing a better environment for the plants to survive, but also the soil microbes and everything that benefits from that. Applying an organic fertilizer helps some soils to retain more moisture as well, so that's more beneficial to the plants around it. The only point I would make with organic fertilizers, we have to remember, because they almost sound too good to be true, and they are, they work very well, but there is still a process involved in creating that pellet. So there is still a carbon process in the background, taking that and putting it into a pelleted form. But as a slow release fertilizer, they have all the advantages of releasing over a period of time, but they also have those sort of soil health benefits as well. So, definitely worth considering on a landscape scheme. Quick product plug, if you'll forgive me, but we have a product in our range called Germinal Slow Release Triphase. And we look at all those things we've mentioned. That has a very small amount, as I mentioned, with any slow release fertilizer, of a quick release at the very beginning. Then most of the fertilizer in there, the 18% N in there, is slow release fertilizer, so the methylene urea fertilizer, which feeds for another 5 to 12 weeks, but then has an organic element in at the very end, which feeds for the last 12 to 16 weeks. So you've got a product there that's going to feed the area you've fertilized uniformly over a 3 months period, which in most landscape situations is probably enough to see that through the entire year. If you apply it in sort of April, then you've got the main growing season covered. Now, one of the objections we get to slow release fertilizers are people say, well, all very well for you to talk about this, but they're ever such a lot more expensive than a compound granular fertiliser. Well, that's true per bag, but when you actually break it down, it's far more economically sustainable as well as environmentally sustainable. And you can read this, but I'll just talk you through this example. If you take a standard compound granular 977 and you're going to fertilise a hectare, so 10,000 square metres, a large football pitch area, you're going to need, at the standard rate of 70 grams a metre squared, you're going to need 25 kilo bags, which at 29.75 is £833 plus VAT. So you're looking at £1,666 per hectare for your fertiliser, because you're going to have to make 2 applications over a 8 to 12 week period. Associated manpower costs, I've spoken to some landscapers, that's approximately £350 a time. So you're looking at a total cost of £2,016 plus your VAT to fertilise that area. If you take something like GSR triphase, you're applying twice as much nitrogen in one hit at 18%. So you only need to apply it at 35 grams a square metre, so half as many bags. So your 14 25 kilo bags at an admittedly higher price of £43 a bag, but that's going to last release steadily over 12 weeks because it's efficient, so you're not losing it, so you're going to get the use of that nitrogen. So you're looking at £602 for the cost of the fertiliser, and only one set of manpower costs with all the savings, CO2 and economical that they're putting in. So when you break it down, you're actually saving £1,000 on your application costs and doing a far more sustainable job at the same time. So just to summarise reducing fertiliser inputs, choose slow release fertilisers. On your landscape schemes, choose a slow release fertiliser. There are many products out there, and the hilarious thing is they have been for 20, 25 years. It's been well known, but I just don't think landscape-wise they get used enough. Even if it's a pre-seed fertiliser, people say, well, I need a pre-seed fertiliser. Any slow release fertiliser can be used as a pre-seed fertiliser because, as we said, the prills are just going to sit there, break down slowly. If the grass takes 2 to 3 weeks to germinate, as the grass germinates, a slow release fertiliser is going to be there to feed that. It doesn't need to say pre-seed fertiliser on the bag. If it's a slow release product, it could be used as a pre-seed fertiliser. And all the other benefits there. You can use a high percentage of N at any one time. It lasts up to 4 times as long. So you've got less bags in total for an economically and environmentally sustainable result. So it brings you on to the crux of our question. Can we eliminate the use of fertiliser altogether? Well, yes, we believe in general landscaping terms, for most general landscape applications, by harnessing and enhancing the core attributes of white clovers, we can do that. So let's look at what's good about white clover. So white clovers are one of nature's synthesizers, along with other legumes such as Bursford trefoil and black medic. They take nitrogen gas from the atmosphere and, using a system of nodules on their roots, they synthesize that nitrogen, can fix it, what's called fixing, fix it and feed it back to plants around it. Mainly grass in grassland areas, but any plant that can take nitrogen up can benefit from a clover inclusion. And we're seeing it potentially used amongst rows in maize crops in agriculture now, because it will feed back to any crop that's around it. If we take the nitrogen fixating out of it altogether, clovers have quite a deep taproot, and they have a network of fibrous stoloniferous growth roots which spread close to the surface and produce new plantlets, and that really improves the soil structure, which, as we discussed before, an improved soil structure improves the environment for all plants to grow. And then the flower on the top, if you like to put it that way, is the clover flowers. Bees and pollinators, most pollinators, but especially bees, love white clover flowers. If you look at most wildlife societies in the UK's top 10 or 20 list of plants for pollinators, white clover will probably be on that list. So I can see everyone sort of sitting there thinking, well, oh, brilliant. Well, so why aren't we using white clover wholesalely in the landscape industry altogether right now? Well, I think the answer to that is twofold. The first point to make is, I think, a bit like a lot of things in the 70s, 80s and 90s, we just got used to using inorganic compound fertilizers. They work really well. I mean, you put them on the grass grows, it's more hard wearing and it's healthier. So they work very well. And until very recently, they were exceptionally cheap. And we didn't really consider the harm they were doing in the 70s and 80s and into the 90s. So they work. So we just got used to doing that in agriculture and in amenity. The other thing on the amenity side is that most clovers today were bred for agricultural use. So they have been used more in agriculture. And because there's a sort of palatability element to anything in agriculture, they were bred in slightly larger varieties. So varieties of clover that we use for amenity were sort of larger agricultural types. And that didn't play well in a landscape setting because inherently all white clovers are not very tolerant to drought conditions and cold conditions, so extremes of temperature. And that's because of those stolons that run across the surface. We said they're not across the surface, just under the surface, but they're very close to the surface and therefore they're very susceptible to extremes of temperature. Now, and they're also susceptible to damage by mowers. Now that's exacerbated if you're using a larger variety as well as so if you're using a larger variety you'd like, so it's even bigger there, it's not blending in with your grass, and so the mowers damage it, and it's stressed by being mown at landscape heights already, and it doesn't persist in the sward. So what we thought was, wouldn't it be great to be able to take the known attributes of white clover and make sure they persist, so that so we had a clover in a sward that wasn't dominating the sward and was persisting year on year on year to produce free, clean nitrogen to feed back to the plants around it. And we go back to that word breeding. Through breeding, we've done it. So DoubleRoot Climate Smart Hybrid Clovers is an overarching name for what we hope will be a stable of clovers going forward, which will enable the landscape industry to reduce markedly the amount of nitrogen fertiliser it uses and provide clean, free nitrogen where currently we're having to reach for a bag of fertiliser. Now, Everlasting is the first variety in the DoubleRoot stable, and it's a world first. It's completely unique. And why is it different? How's it solved these problems? Well, the crux of it is that it's a cross between a standard white clover, Trifolium repens, and a Caucasian clover, Trifolium ambiguum. Now, taxonomically, it's still a Trifolium repens. It's a white clover, but crucially, as well as those stolons that run just under the surface, it has rhizomes. Now, if you look on this picture at the back there, you can see those thicker, chubbier roots, for want of a better word. Rhizomes spread deeper under the ground, and they'll pop back up and produce another plantlet. Only one plantlet, but they're another way of spreading, of a plant spreading. Now, because they run deeper under the ground, they're more protected from that mower damage, that extreme cold event, and that extreme drought event, of which we're getting more and more in our environment now. So it gives a second way for that white clover plant to come back should it have a poor time through any one of those three, situations that used to be potentially terminal to it. So its benefits, we say, an enhanced ability to improve soil structure. Because it's got those rhizomes, it produces a better soil structure than a normal white clover. Now we have two soil samples here, or cross sections of soil. Now this isn't everlasting against another white clover, it is just an everlasting against no clover at all. But you can see there the benefits of a clover in a mixture there. You can see the benefits of the soil structure. You can see how there's more macropores there, how that soil is healthier as a consequence of that thick root system in there. And that's particularly important on landscape schemes, because as we all know, housing projects, road verges, by the time we come to sow the grass seed on those projects, that soil is compacted generally, even if we take some rudimentary attempts to sort of break that compaction. So just using a good clover like everlasting on those areas helps life out in that soil anyway. And it's very small leaf, but what you can see is the small leaves there. The leaves on aberlasting are exceptionally small. It's bred for amenity use, therefore it will exist in the bottom of your grass sward and it won't dominate and take over. So, you know, it's in balance with the sward you're trying to establish. So with those rhizomes and those stolons, you can see a cross section here. You can see the small leaf clover in amongst the grass there. It's fixing the traditional weaknesses of standard white clovers. It's drought resistant, it's cold tolerant, and it's not susceptible to mower damage. Consequently, it will persist to continually deliver the benefits of white clover, mainly that free, clean nitrogen year on year on year. Whereas before, you might have been using a white clover, but it was, you know, after a year or two, it wasn't there. It was leaving the sward. And while it's feeding clean free nitrogen, we're not applying nitrogen that we don't need to. So it's a very clever way to solve that problem. Now, it won't escape your attention. Some people think, well, you know, but some people disregard clover, don't like the look of clover within a grass sward. That's definitely true. I mean, even when you see this there, people are still going to have to accept that there's clover in a large urban area or even in lawns going forward. But I think with the innovations such as No Mow May, I think the upcoming RHS show is going to change perceptions of this as well. From what I've read in the press, I think people's perception of what a lawn is, I think in 15, 20 years, you might say to people, the idea that a lawn is a monoculture of grass, I think that's going to change quite rapidly in the next, through necessity and through just public perception. So I think, you know, an acceptance of different plants and different textures in a lawn will grow quite quickly in the public consciousness. So just to touch on the nitrogen fixation specifically, aberlasting will fix between 5 and 20 grams of nitrogen per square metre per annum. So that's 50 to 200 kilos per hectare. Now, if you look at the Sports Turf Research Institute recommendations for even a high intensity sports pitch, they're suggesting between 150 and 250 kilos of N per hectare per annum. So 50 to 200 kilos is more than enough to feed any general landscaped area, even a landscaped area, you know, a park in Gateshead where they play a lot of Sunday league football, you know, it's going to be fine for those purposes. And the clover flowers are beneficial to bees and pollinators. I mean, areas where you leave it slightly long, you're going to get those clover flowers, and they're going to be utilised by bees. And even low down, if you're mowing a public open space that's sort of no shorter than 40 mil, then you're going to get some flowers in there as well. And on road verges, it could be fantastic, really. Just, you know, blankets of it, which will really benefit pollinators. Hang on, I'll flick forward there. So how do you use double root in a mixture? Well, if you're sowing from scratch, really just use it as part of as an appropriate amount as part of a standard mixture. So our A18, our road verge, our motorway mixture now includes aberlasting as standard. It always used to include a white clover, but we now got aberlasting in there. So we like I say, so we're making sure we've got a clover in there that persists. For a large landscaped areas, public open spaces, we have a product called AberSustain, which is a mixture of low maintenance grasses and clover in there to feed those grasses. You'd sow one of these mixtures at a general sowing rate, your general landscape sowing rate of 35 grams a square metre. The only thing you might want to do is, clover likes a higher soil temperature than grass seed to germinate. So in order to get that quick establishment of that clover, you're probably 1st of April at the earliest to mid-September would be your best sowing window. The extremes either side, you will get the clover established, but it's much better to sow it at a time of year when you know, a more traditional time of sowing, because you want the minimum soil temperatures there of 10 degrees centigrade. Going to sound like a paradox now, but the use of a slow release fertiliser is advised when sowing. On most soils, you probably don't need to, but to sort of kickstart any mixture, a bit of slow release nitrogen is worth having, because it gives the clover something to work on in the first instance to sort of start synthesizing. So, you know, a slow release fertilizer if you were establishing from scratch may be beneficial, but then after that, the whole point is you're not needing to feed any N on that environment going forward. Now, we launched, sort of soft launched DoubleRoot at Soltex last year, the big trade show, and we were actually surprised at the amount of inquiries we had from people that were, and we hadn't thought through this one really, that were looking to, were contracted to look after public open spaces, and we're currently feeding them once or twice a year, and we're looking at the option of stitching clover in, which is done agriculturally all the time, stitching clover in to fix that nitrogen and negate the need to go and fertilise at all. And that is perfectly possible. What you do, again, you want to really pick a time of year when, if you're stitching clover in, you want to pick a time of year when it's very warm and moist generally. So late August, early September would be the ideal time. But again, any time between April and September, but moisture is key. So avoid really dry times. But any time when the conditions are right, if you reduce the competition from the existing sward by scarifying or harrowing, and any good landscaper will know what those techniques are, create some bare areas through scarifying or harrowing, and then broadcast clover on and lightly roll it in. You're just pushing that into the surface, and you will get establishment within that sward. The oversowing rate is quite small, so only 5 grams a square metre. So you're looking at 50 kilos a hectare. So a little bit goes a long way. But the best way to do it would be to use a purpose machine. A bit of a plug here for Vredo, but these machines, these disc seeders that just put a disc through, just open the surface up, and you can just drop a clover plant in. They're ideal, really. Scarification, and then you run over with a purpose-built disc seeder, and that's a great way to get clover incorporated into existing areas, and then be reducing the amount of fertiliser you're using going forward. So, in summary, traditional white clovers have many benefits. They're inbuilt, that's inherent. They fix nitrogen, they improve the soil structure. But DoubleRoot hybrid white clover, aberlasting, remains in the sward perpetually in a landscape situation to continually sort of feed that clean free nitrogen and negate the use for nitrogen fertilisers. And that's why we think it's a must going forwards. Thank you all for coming. And if you do have any questions you'd like to ask, you can contact us at, if you go on to germinal.amenity.com, then there's many ways to contact us and ask myself or any of the Amenity reps on the road questions about DoubleRoot or anything else we do. Thank you very much.